I'm experimenting with water cooling and heat sinks, just kind of for fun. I would like to work on some projects that would involve high power MOSFETs or power transistors, and of course, when you're working with semiconductors that are carrying a lot of current, they want to heat up, and so you can run more current through a smaller transistor if you have an effective cooling system. So what I've got is, this is a heat sink out of something that was torn apart, right? And this guy is a thermistor, probably from an old 3D printer, but it's a simple temperature sensing device. It may be accurate within a few degrees. I haven't bothered to calibrate it or anything. And so the water will flow through the heat sink from one end to the other. And I have the temperature sensor at the entry. So it says how warm the heat sink is at the where the water is entering the heat sink. I think it would be cool in the future to have one where the water exits and see if there's a difference in temperature whenever you do have a hot, something generating heat. You could actually measure how much the water flowing out has heated up compared to what it is going in. Anyway, I've got an Arduino back here with it's pretty much the thermistor going straight into the Arduino with I've got a pull-up resistor to create a voltage divider, and that produces a voltage from the thermistor resistance. And then it's programmed to generate a frequency that is 100 hertz or 100 cycles per degree Celsius. And I have two devices measuring the frequency just to see what they, and actually both read 2.119 or 2.119 kilohertz, and if you divide that by 100, that's 21.19 degrees Celsius. And that is probably a little bit under room temperature. I think it's around 23 degrees in here, degrees Celsius. If I take out the thermistor and just hold it between my fingers, you can watch the temperature rise. 27, 28 degrees. The oscilloscope agrees with me. 29, 30, so about 30 degrees. I think my body temperature at my fingertips is around 31 or 32 degrees. If this sensor is at all accurate, it's probably a couple degrees off. Okay, so of course these are just fans, DC brushless motors. That's pretty much across the board what cooling fans are. And that's nice because they don't have any sparking brushes that could, I don't know, they may not do as well underwater. I think that these are plenty safe running underwater. And I have bunches of them, so I'm not super concerned if they do end up dying. This is just an experiment. So the next thing that I would like to do is apply some heat and see what that does. Kick it on to high, and I'll aim it on the intake side of the heatsink, which is where the thermistor is, and try to keep it off of the actual plastic fans. And immediately we do see that the temperature is gradually rising. It's increased about 1 or 2 degrees Celsius. And still on the rise. So eventually what will happen is the heatsink will begin to warm up, which will actually cause the water to also warm up. Now the water is dissipating heat into the air, and so is the heatsink. So at some point, the rate of heat entering the system from the heat gun will match, or it will equal, the amount of heat being dissipated into the air. It's been 3, maybe 4 minutes of heat gun on high, and the temperature is now about 35 degrees. So that is almost a 10 degree, that's a little over 10 degrees because we started around 22. So that's, and remember that water boils at 100 degrees Celsius, so we're pretty far away from that. It is still heating up, 36 degrees. Temperature's still climbing. We just passed 40, and now we're at about around 42. Maybe about 7 or 8 minutes in, and we're at 45 degrees at the sensor, and the water is warm to the touch. So it's probably, it's close to body temperature, getting up on 100 degrees Fahrenheit, or 98 something, perhaps. So the temperature is increasing more slowly now, and we have to wait longer before it increases a degree. We're at around 54 degrees Celsius, and it's difficult for me to keep it that hot, even just moving the heat gun or aiming it in a slightly different direction, and the temperature will drop. So I'm going to say that we're pretty close to the point where the temperature of the, things are starting to equalize, I guess. So now what I want to do is figure out how much the water has actually warmed up, and I can feel it certainly is warm, and the pan is going to be pretty hot. So let me just pop this sensor out of here and put the probe decently far away from where the heat was, just to see what has been going on somewhere else. And it appears that the temperature of the water, we'll give it a second to, it's still dropping. No, I'd say it's hovering around 44 degrees Celsius, which is a 22 degree increase, and the heatsink unit was 54, which is a 22, that's a 32 degree increase. And yes, the pan was very, very hot, but the heatsink was much cooler, obviously. So now I'm just curious how long it will take for the heatsink to return to room temperature, for the water to return to room temperature.